Welcome to section 3.5, which is overlapping triangles, and today we're looking at what happens when we have more than one triangle sharing a common space. Our goal today is to be able to figure out what those triangles are and to be able to prove them congruent. So as far as the proofs go, there's absolutely nothing new. If I gave you the diagram and separated those triangles out for you, you'd easily be able to do these proofs. The trick is going to be able to visually pick those out, and that's what we're going to work on today. So BR is congruent to AE, BE is congruent to AR. That's information that's given to me, and I'm going to go ahead and mark that off, and I'm going to use my green pen here to mark those. BR congruent to AE, and also BE congruent to AR. From there you can tell I've got two pairs of sides that are congruent, and I'm trying to eventually show that angle B is congruent to angle A. I'm just going to kind of circle those so I can keep those in mind. From here, there's a couple different ways, a couple different triangle pairs that I could potentially pick. I could pick triangle BDR and triangle ADE. They do have the two pairs, or parts of the sides anyway, that are congruent, but I can't easily see a way to prove that those two triangles are congruent. There is another pair of triangles that is a little more apparent with what I've got. So if I just highlighted BR, and I'm going to highlight AE in a different color, we'll go with green, and I go back to my original triangle. BE is the other segment I know. Maybe this triangle is starting to pop out at you. And that's supposed to match up with AR. And then in addition to that, it seems like we could easily complete this triangle by highlighting those sides. The triangles that we want to prove congruent, and I'll write these out. We're not going to do the proof because, like I said, it's relatively easy. We can do that in class. We're going to say that triangle BRE and what's supposed to match up with B is A, and BR matches up with AE, so this would be AER. And if we can show that those two triangles are congruent, then we can prove B is congruent to A. And if we were to do the proof, we would say here in the next step, after our given information, that angle or segment RE is congruent to segment RE, and that's the reflexive property. And that would give us the triangles congruent. So again, we're visually picking out those triangles to figure out which ones are we proving, and then do the proof. If you need to draw them out separately, go ahead and do that. It might help you complete the proofs a little easier. Example 2, we're given something about angles. Angle AWT and angle EWR are congruent. Angle A is congruent to angle T, and AW and TW are congruent. So as you can tell here, we have definitely two pairs of segments, or one pair of segments, AW and TW. So I'm going to mark off my TW segment in green. We'll go back to our trusty magenta for AW. And I've got these angles here, so I think because I've got this whole angle, I want to make sure that the side that forms that is also included. So hopefully at this point we can see that, well, this triangle almost, oh, there we go, there's the remaining piece, WR. And the remaining piece for the other triangle is WE. So when I name the two triangles, I'm going to name them in the proof once I actually do it. I'm going to name them, we'll go WAE, congruent with the triangle WTR. And I eventually am going to use angle side angle to do that, but if you look, I have kind of this partial angle, so I need actually the entire thing, and I'm going to get the entire thing by using the addition property to show that angle TWR is congruent to AWE. Then once we have the triangles congruent, we're going to pick out the parts. Again, nothing new in the proofs. Last one, we have angle OTR is congruent to angle HRT. Mark those guys off. OT is congruent to HR, and that's what we're given. And we're trying to show that OR is congruent to HT. So in reality, I don't care about a lot of this stuff here at the top. It really doesn't affect the proof that I'm trying to complete. So if I marked off angle OTR, sometimes marking off the angle gets you really good results really quickly, and you can very easily see which triangles, oops, let's try that again. You can very easily see which triangles are going to be congruent. And then the other angle was angle HRT. And there's our missing part of that triangle, and there's our missing part of that triangle. So the triangles that I'm trying to prove congruent will be triangle, well, why don't we name it the way we just did, OTR, and HRT. And based on this one triangle, triangle OTR, I can see I have a side and an angle, and I'm going to need that side. Side, angle, this side, again, it's reflexive property, they share it, so that's going to be my third piece to get the triangles congruent by SAS. Then I'll pick out the parts using CPCTC. So again, the main idea of this section is the proofs are no different, it's just a matter of picking out the two triangles that you need to prove congruent first because they overlap.